Ever stop and think about what's actually ticking away inside your phone, your car, or even your hard drive? Well, it turns out that billions of these devices are all powered by a single, really elegant idea. An idea that won a decades-long war of philosophies. So let's dive in and unpack the story behind this quiet technological revolution.
What if I told you there's a hidden design philosophy literally in the palm of your hand right now? It's all about a fundamental battle between two opposing ideas, complexity versus simplicity. And as we're about to see, the winner is absolutely everywhere.
But before we get into the nitty-gritty, let's just talk about impact. One of these philosophies gave rise to an architecture called ARM. And by 2015, ARM wasn't just another player in the game. It was basically the only game in town, powering almost everything. So how on earth did that happen?
To really understand ARM's incredible rise, we have to go back, way back, to the beginning of a huge conflict in computer design, a real battle for the brain of the machine itself, the processor.
Okay, so it all starts with the original champion, the first big idea for how a processor should work. Let's meet CISC. CISC stands for Complex Instruction Set Computer. The core idea here was pretty straightforward: make the hardware do more of the heavy lifting. That way, life would be easier for programmers because the processor itself would understand very specific, very complex commands.
You know, the perfect way to think about CSIC is like one of those giant Swiss Army knives. It's got a tool for literally everything you can imagine. Need to open a can? Check. Need a tiny little screwdriver? It's in there. But if all you want to do is slice an apple, pulling out this big, clunky thing feels like overkill, right? It's just not that efficient for simple jobs.
So why did they go down this road in the first place? Well, early CPUs were, let's just say, pretty basic. But programming languages were getting a lot more sophisticated. So designers tried to bridge that gap by adding specialized instructions right into the hardware for things like handling strings of text. The most famous example of this? Intel's x86 architecture. Yep, that Intel. It powered the entire PC revolution using this CISC philosophy.
But that Swiss Army knife approach, it came with a hefty price tag. All those complex instructions needed more circuitry, and more circuitry means more power. A lot more. Plus, each of those fancy commands could take multiple ticks of the processor's clock to actually finish. And the real kicker, it turned out a lot of those specialized tools were barely ever used in the real world. So here was the crucial flaw. All of this extra complexity could actually slow the whole thing down.
And that performance problem opened the door for a completely radical, counterintuitive new idea. An idea that wasn't built on complexity, but on the raw, incredible power of simplicity.
And this is where RISC comes in, the reduced instruction set computer. The philosophy here was the exact opposite of CSIC. It was like, forget trying to do complex tasks. What if the hardware only did a very small number of super simple tasks, but it did them with absolutely blinding speed? So if CISC is the big, clunky Swiss Army knife, RISC is like a professional chef's kitchen. You've got a set of perfect, simple knives. Each one does just one job. It slices, it peels, it chops, but it does that one job flawlessly. And a master chef, or in this case, a smart piece of software, can combine those simple moves to create anything they want, far faster than someone fumbling around with a multi-tool.
This less is more approach had this amazing ripple effect. A simpler design meant less circuitry, which meant way less power consumption, a total game changer for anything running on a battery. And because the instructions were so simple, most of them could be executed in a single, lightning-fast clock cycle. The result was kind of a paradox. By doing less with each individual step, the overall performance just went through the roof.
So, now we've got our two contenders. In one corner, the complex, all-in-one approach of CISC, and in the other corner, the simple, brutally fast philosophy of RISC. Let's put them head-to-head.
First and foremost, the most fundamental difference is the instruction set itself. With RISC, you're dealing with a small, simple set of commands. CISC, on the other hand, is working with a huge, complex dictionary of instructions.
And that one difference leads directly to the bottom line, execution speed. Because each simple instruction is so quick to process, RISC is just plain faster. CISC, with its complex commands that take multiple cycles, is inherently slower.
This table really gives you the full picture. I mean, look at the number of registers. Those are little, super-fast memory spots right on the chip. RISC has tons of them, keeping data right where it needs to be. CISC has very few. Or look at the control unit. RISC is hardwired for pure speed, while CISC uses that slower microprogramming layer we mentioned. From top to bottom, it's the same story, simple and fast versus complex and slow.
So here's the crucial point. This entire fight between CISC and RISC is really about one thing. What is the most efficient way to translate the code that humans can read into the billions of ones and zeros that the machine actually understands? CISC tried to solve that problem with powerful, complex hardware. RISC trusted simpler hardware and smarter software to do the job more efficiently.
And that brings us to the company that took the RISC philosophy, bet everything on it, and used it to conquer the entire world of mobile and embedded computing.
I mean, it's right there in the name. ARM stands for Advanced RISC Machines. It's not just a company, it's a whole family of processors built entirely from the ground up on the principles of RISC that we've just been talking about.
ARM's journey is just fascinating. They started out as a British company called Acorn, which made a hugely popular computer back in the 1980s. But then they made a genius move. They pivoted. They decided to stop building the computers themselves and to just focus on designing the most efficient processor cores based on this RISC idea. And wow, did that pivot pay off? The low power and high performance of their RISC design was the perfect recipe for the mobile revolution. This is what complete dominance looks like. 85% of application processors, 90% of storage controllers, 95% of automotive processors. That is the incredible power of a simple idea. And here is the secret to their success. ARM doesn't actually make any chips. Instead, they design the processor cores, the intellectual property, and then they license that design to hundreds of other companies like Apple, Samsung, and Qualcomm. It's a brilliant business model that allowed for massive innovation and put an ARM processor and the RISC philosophy at the heart of nearly every mobile device on the planet.
And that brings us right back to you. The incredible little supercomputer in your pocket is a direct result of this great design debate. Its speed, and maybe more importantly, its amazing battery life, is a testament to the idea that sometimes the most powerful approach is the simplest one.
So, the RISC philosophy of simplicity, efficiency, and low power was the undisputed winner of the mobile age. But that leaves us with one last, fascinating question. As we move into a new era of AI and quantum computing, what design philosophy, complexity, or simplicity is going to power the next great technological revolution?